Today's adventure is a 2017 Suburban. This also applies to Tahoe, Yukon, Silverado, and Sierra. Got a trailer brake system warning message. This seems to be pretty common. So first step, I've got a message on the dash. That means I must have a problem right now. So first step is to check the codes. Here's all the codes that we have. Looks like we got a U1556 lost communication with device on LIN bus set by the chassis control module, set as current. This is the only code I'm going to care about. So next, what I would want to do is go look at the LIN schematics and see how many LIN devices are on the chassis control module. Okay, so here we have the LIN schematic that contains the chassis control module. This is going to be pretty easy because there's only one device on the LIN network. LIN stands for Linear Interconnect Network, also known as Local Interconnect Network, and essentially that is a direct network connection between a master device such as the body module, the chassis control module, instrument cluster, etc., and these slave devices that they communicate back and forth. So since the chassis control module is setting our U1556 as current, it means that in this ignition cycle it has failed to receive a message or a response from the trailer brake control module. So this should actually be fairly easy to diagnose. I'm going to show you what I would do to come up with an answer. So here we have the schematic for the chassis control module, and it shows some more details. This circuit right here, 4114, is the exact same LIN circuit that is shown on this schematic. I'm going to show you most of this part from the driver's seat because that's how I do a lot of my DAGs. We need to first review how the system works and then make logical decisions on what can and cannot be the problem. For example, we have a hot at all times. They come from two separate fuses, but I have a hot at all times to the chassis control module. I also have a hot at all times to the trailer brake control module. I have a ground at all times from the trailer brake control module, and I have my LIN circuit. So I only really have 1, 2, and 3 circuits to check as to why would this not communicate to the chassis control module. Because if I have power and ground, the module should theoretically be able to power up and respond to a communication message back and forth. So we need to make sure, do I have power at all times here? Do I have ground at all times here? And do I have a good communication circuit back and forth? So the first question I would ask is, do I have power and do I have ground? Notice they share a common power source. They share a common ground source. I already know that the chassis control module has woken up and responded to my code request, so he is therefore communicating. So therefore this ground must be good in some way, and I must have some sort of power here in some way. So probably the easiest, fastest way to diagnose this problem would be go directly to the trailer brake control module, disconnect that connector, and I'm going to check power, ground, and I'm going to check this LIN circuit, and it's going to be really easy. Before I do that, which may require crawling underneath the vehicle or maybe putting it up in the air so I have access, if I remember correctly, the spare tire is actually in the way too, so I might have to remove the spare tire. It would be really easy to get under this underhood fuse block and check these two fuses. I think this one would have to be good because the CCM does communicate. This one may be popped, and really the only reason that that fuse should blow is if you had connected a trailer on that connector with a short circuit or maybe a wiring shorted here. Really, it shouldn't blow unless there's a wiring fault or a trailer fault. The customer told me he never tows with this vehicle and he's never plugged anything in, but turns out customers lie, so I don't know what to say about that. Trailer brake control module is located up here, so you definitely need to lower the spare tire for some access. Bonus content, found your hidden key. Gonna have to get into this panel, grab the jack tools so I can lower that spare. I'm just gonna assemble these rods. Stick it in the hole. Stick that on there. And I just loosened it enough so I can drag it out of the way and work on her here. Okay, so here I am back underneath the vehicle. This is the chassis control module. This is the trailer brake control module. And this is the fuel pump driver control module. Notice these two look identical, as well as the connectors almost look identical. So I had to verify the color of the wiring and check against the schematic to confirm that this is the one I need to be testing. When they're real dirty and dusty like this, they're almost certain to be a challenge. It's already given a fight. When we move, usually they will break. Yep, just got a mouthful of dust. Try to wiggle that. Jeez. Real stuck. Okay, any green crusties? No, nothing obvious, so now I can do my circuit testing. Look how many wires come out of this thing. Look how simple this is. Logically, the main power and ground feed would probably be these two big fat wires, right? So if I test across these with a test light, it should light because this is supposed to be ground at all times and power at all times. Here what I've done is I've installed the diagnostic test probes onto the test light, and I just want to make sure that my test light's actually going to work and that I can trust it. Yep. Okay, now I'm good to go do my test in the back. Try and do this one-handed. We've got power and ground at all times. That's good. Okay, we've only got one more circuit to test. We got to test the LIN circuit, which is the green, I believe it's this little green wire. The only way that I really trust to test a LIN communication circuit is with a lab scope. So I'm going to get the lab scope out and I'll show you what that looks like. I happen to be using Picoscope today. You could use just about any sort of lab scope, digital storage oscilloscope. You could even use the old school analog scope if you knew what you were doing. Before I go hook up to the vehicle, I'm going to do some setup. I want to change my time base to about 100 milliseconds per division. Each square box would be 100 milliseconds, maybe 200. Just so I can see it over long term. I know that the vertical range of a LIN circuit is nearly 0 to 12 volts, so I want my range display to match that. I'll put it on, is it gonna change? Yeah, there we go. So here, my signal should fit 0 to 12 volts. When I connect to that circuit, we're going to see what it looks like and go from there. Okay, so that's what we're looking like before we touch the probe to any of the circuits. Okay, I'm going to test via a front probe on the terminal because if you back probe here, you may miss a faulty terminal and that will lead you astray. So I'm going to test right here from the front probe. Okay, I've got my probe in and this is what the signal looks like. And we're still basically stuck right there at 0 volts. Here's what it looks like when I disconnect it. You can see a very slight change. I could even change the time base, make it easier to see, 1 second per division. And then you can see those small changes I'm making. This is when I disconnect and replug. So there's something going on this LIN circuit, but it appears to be shorted to ground, or possibly there's so much wiring resistance that that's what we're getting. You know what? It makes a big difference if you actually turn the key on. So this actually appears to be a normal LIN circuit. Maybe I'll take a closer look at it, but it does look okay. I'm gonna let this run, and then I'm gonna pause it. So we're gonna pause. Window zoom, just zoom in, small portion. Dang, those look like some real good, clean signals from a computer. This is a signal pulling that down low, 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 high to send a message. So our power and ground's good and our LIN circuit's good. That must mean we have a faulty trailer brake control module. So I'm gonna call this a faulty control module. I'm already down here so I can get this 8-digit part number fairly easily. I've proven that the module has power, ground, and communication circuit right up to this connector. So I've therefore proven this is a faulty control module. And again, the lab scope is really the only tool that I fully trust when testing data communication circuits, simply because you can see the quality of the signal. You can see if there's any sort of noise. A digital on-off signal should be straight up, straight down, vertically like that. That's definitely a good signal. I'll show you, since a lot of people do not have a lab scope, alternative test procedures on a LIN circuit, but they're not as trustworthy. So this is what a regular voltmeter would look like on a normal LIN bus circuit, but that may vary depending on how many devices on the circuit you have communicating. I really would not trust this as a diagnostic. Okay, so I showed you what normal circuit voltage might look like if you were using a voltmeter. I absolutely do not trust that method at all. So what I would do is I would disconnect the connector here, disconnect the connector here, and I would use my ohm meter to test end to end. Is this wire good? Meaning low resistance, I should have 1 ohm or less. And then I would test for continuity from on this wire with everything disconnected. This wire test continuity to ground and test continuity to battery positive. Both should be near infinite resistance, meaning no connection between this wire and ground or battery plus. That's how you would prove that this wire is okay if you did not have the lab scope to actually look at the computer signal. Disconnect the battery before we replace that module. Always a good idea to clean out the connector. Here's the new module going in place. Really easy, just 2 nuts. Okay, all we gotta do is plug this connector in, hook the battery back up, turn the key on, and await our results. I'll have to wiggle that close. It's all dirty, packed with dirt. Oh, look at the little face. Bonus content. So here's the old module. Take a look at that. Why did it fail? Well, it's just kind of a terrible location. I don't really know why it failed. I just see a lot of them fail, and I assume it's because of the mounting location. Of course, it's a good idea to clean the battery terminals since I've got it off. Okay, let's key it up and see what happens. Hood's open, we already know that. Let's play with the trailer brake system. Play with the buttons. Hey, looks like the trailer brake system is now working. That wasn't too bad. Well, that's all I got. So to summarize, we had a service trailer brake control system message on the instrument cluster. We checked the code. We found that the chassis control module auxiliary had set a lost communication with a LIN device. We determined that there was only one device on the LIN, trailer brake control module. We verified power, we verified ground, and we verified a good LIN signal, thereby proving that the trailer brake control module should have everything it needed to power up and start communicating and doing its job, but it was not. So we replaced the trailer brake control module right here, put in the new one. The new one does not need any reprogramming. It's plug and play. We keyed it up and it's fixed.